Hey guys, welcome back to another software engineer interview question. Today's question is to reverse a singly linked list using recursions or recursively. Now, you can do this iteratively or recursively. In this video, I want to discuss it recursively. In the next, I'll go through how we would do this iteratively. So as an example, you can see we have a linked list that goes from 1 to 5. And then 5 points to null, and then the answer to this is 5, 4, 3, 2, 1, and 1 points to null. So it's completely reversing the linked list. Now I also have a basic setup that you can copy here, or you can come up with your own, but I create a basic list node, which is just a class that has an integer for the value, and a list node that's pointing to its next node. There's also just a constructor so that we can assign the value very quickly. Then in the main method, I create 5 instances of node, passing in all the values 1 to 5. I'm trying to do the exact same example. So I have all my nodes, and then I create my connections so it's very clear. So node 1 points to node 2, 2 to 3, 3 to 4, 4 to 5, and then 5 to null. So that creates my link. And then I have my method stub, which is just a method called reverse recursively. It takes in the node, and then it will return a list node. This list node that it returns should be the new head of the list. So when we call reverse recursively from the main method, it will return that new head, and then I print that head, and I created a simple print method for us, and it just iterates, or it just iterates through the linked list and prints out all the elements. So after we run this example and after we implement this, it should print 5, 4, 3, 2, 1 with this basic setup. Like I said though, you can write your own basic code to test the program. This is just an example that you can use, but there's many other ways you could test this out as well. So I'll go ahead and pause for a second to give you an opportunity to pause the video and attempt it on your own. And then we'll come back, we'll go through the logic in PowerPoint, and then we'll come and implement it. All right, guys, welcome back, and hopefully you had some time to attempt this on your own. But now let's go through it together. And you can see I just recreated our simple example of 1, 2, 3, 4, and 5. And 5 is the end of the list by denoting it with pointing to null. Now this is a tricky algorithm only because we're doing it recursively and it's a little bit confusing. So I'm going to try to illustrate the call stack by using some colors, as you'll see in a few minutes. But let's first try to understand the problem at a high level. So remember, this is a recursive method. So the first call will be from the main method and it will pass in the head of the list. Remember, the head of the list at the beginning is 1. And when we start at 1, we need to get to 5 eventually, right? Because at the end of the day, that first call to 1 needs to return the head of the new list, right? Because the caller, the main method, is expecting the new list to start at 5. So we already know that the first call to this method, which is the node at 1, it needs to have a return value of 5. And if you look at this list, 5 is the last element, which tells us we need to travel deep. We need to go all the way to the end of the list, which is typical what you would do in recursion. We need to travel all the way in till 5, and then once we hit that 5, we should hopefully hit our base case, which will then allow us to go backwards and finish up the algorithm. But as you can expect, since the first call to this method or at position 1 is going to return node 5, because that's the reverse, that means that node 5 needs to be returned all the way from the end, all the way back to 1. So we can just already, before we get into the algorithm, we can assume that we're going to be returning 5 from here to there, to there, to there, to 1, and then 1 will return it back to the main method. So we know there's some basic flow already. Now, in all recursive methods, we need to have a base case. The base case indicates how this method is, or how this recursive call is going to terminate and stop recursively calling itself. And in this case, remember, our goal is to get to the end. We need to get to the 5 at the end so that we can essentially return it all the way back. So our base case is going to include two parts, but one of them is going to say, hey, if the node that we're currently at's next node is null, then we must know we're at the last element, right? Because null indicates the end. So if the next one's null, then we know we're currently at the last element. So that means our base case is this. And like I said, there's two conditions. The first condition is if node is null, return node. The second is if node next is null, return node. Let me explain the first one. The reason why we have if node is null, return node, that is simply only there so that if the caller passes in an empty linked list or null basically, then we'll just return that null back. And we're not going to go into our logic, which will then crash the program because it's null. The second one is there to catch the end when we reach 5. So as you can see, when we hit 5, if node was 5, 5.next is null, so we return 5 back to the previous caller. And I'll show you that flow, but that's our base case. Remember, this is so that we can find the end of the linked list and then start sending it back. Remember, we want to send 5 all the way back to the beginning. So, like I said, let's actually go through this algorithm step by step, and I think it will make sense. So, the main method calls our recursive method, and we enter in our first iteration, basically. So, the call stack is currently pointing at this gray call stack, our first iteration of this recursive call. So at this point, node is 1. We're currently looking at node 1. And I created this extra variable called head. Because remember, when we get all the way to the end, we want to send that last node all the way back to the beginning because that's the start of our new linked list. So I'm going to be using this extra variable called head to keep track of the new head. But its value is only going to be assigned on the way back. When we're going into the stack, it's not going to be because we haven't reached 5 yet. But once we reach 5, we can send it all the way back and you'll see how. All right, so we start at 1. 1 is going to call into 2 recursively because remember, we're trying to hit our base case, which is the last element. So then 2 calls to 3, 3 calls to 4. And notice how the purpose of these colors is to indicate the call stack. So on each color, that represents the current state. So for example, if we take node 2, in that call stack, there's 2 variables. There's the node variable, which is pointing to 2 itself right now. And then there's head, which is currently null. So this is the stack or the state of that stack. And then finally, we get to the end. Now at the end, right, if we read our base case, is node.next equal null? Well, yes, node is 5, its next is null, so that is true. So it says return node. This is what we need to do. We need to return node because remember, we're trying to send it all the way back. So the system goes, okay, return node 5 back to the previous caller, right? Well, we're returning it to 4 because this is a recursive method and 4 called 5. So we're returning it back to 4, and then 4 will just store this in that extra variable, head. So we keep that 5 there. Great. But now the hard part comes. Head is now holding 5, but we need to now fix up this linked list. Because remember, we need to reverse these all. So essentially, 5 needs to point to 4, 4 needs to point to 3, and so on. Well, how are we going to do that? And this is what a lot of people get tricked on because this statement that I'm about to go through is kind of confusing if you just initially read it. But we're currently at node 4 and we need 5 to point to 4. So how do we do that? Well, if we're at 4 currently, which is node, so I need to go to node's next, which is 5, and I need to tell 5, hey, point back to 4. So node.next is 5. And then 5's .next, I need to say, is 4. Let's look at the answer. So it's node.next equals node. That's how we would do this assignment, right? Let's think about it. If our current call is blue, so we're at 4. 4.next is 5. And then I'm saying 5's .next is going to be equal to node, which is 4. So it's saying point 5 to 4, its previous element. So that does this. So this is our current representation in memory right now. 5 is pointing to 4 and 4 is pointing to 5. But we don't want 4 to point to 5. We want essentially the end of the linked list to point to null. Since this is currently the end of the linked list because we're going to keep on going backwards, let's now point 4 to null by saying node.next equals null because node is 4 currently. So that would then point that to null. Great. And then this process repeats going through the backstack as we're going all the way back. So remember, we need to return 5 all the way to the beginning. So we'll return 5 from here. So then this new iteration, the current call, is this tannish color. So 3. And then we do that same process again where 4 points to 3. So it's that node.next.next equals node. So 3.next is 4, and then 4.next is 3. So 4.next equals 3, looks like that. And then we'll say node.next equals null, so 3 goes here, and this process just repeats. I return head or return 5 all the way back. So now 2 has that 5, which is the head of this new linked list. Then I do my next, which points 3 to 2. And then I do my next equals null, which points 2 to null. And then I return 5 again. We're almost there. Once 5 is at this first node, I do the same node.next equals node. So 2 points to 1. And then node.next equals null. And there you go. Now the last thing to do is we return head to the caller, right? Who called this method, right? That's the main method. The main method called here into this method to start it off, and I'm returning 5, or the node that represents 5, right? If we return 5, we now have a complete linked list. Think about it. If main gets this back, but gets 5 as our head, it will see a list that starts at 5, that points to 4, then 3, then 2, then 1, then null. And that is the reverse linked list. So that's the breakdown at a high level. I know it's a little bit confusing with that next call, but maybe when we implement it, it will make more sense. So let's go ahead and jump back to Visual Studio and implement this logic. All right, guys, welcome back. So let's go ahead and go through this logic of reversing a linked list. So let's scroll down to the stub that I had before, the reverse recursively method that takes in the node right here. And remember, normally when you build a recursive method, you define the base case first. And we defined that in the PowerPoint. We went through that the base case is 2 different cases. So we'll say if node equals null, so if the node coming in is null, then obviously we're going to return null because there is no linked list to reverse. And the second is if node.next is null. So that is to represent if we're at the end of the list, because when we're at the end of the list, the next node is null. And in either of those cases, we're going to return node. And that's fine, because for the null case, if node is null, we just return null. And then if node here, if the next is null, then we'll return the current element. So in our example, that's like when 5 all the way gets to the end, 5's next is null, so we return 5 to 4. And you'll see how that looks in the code. Okay, so now, since when we went through the demonstration of this, the goal was before we did any reassignments, remember before we reassigned, node.next equals node, before we did any of those to rearrange the links, we had to first find the end, which means that we dive first before we start rearranging. So that means the recursive call is going to come first before any of the manipulation of the links. That's just how it works based off of our illustration. So that means that we need to say reverse recursively passing in something. All right, I'll put an X for now. So every time we call, we want to get deeper into the links, which means when we call, we want to go to the next node. So every time we recursively call, we say node.next. So we start at 1, and then this calls to 2, then 3, then 4. And remember, this method, which is itself, returns a node. So this means this is going to return something. So we know from our demonstration that our goal is to get all the way to the end. we return the last element, and then we keep on returning that back through each call stack iteration, and that represents the new head so that we can return the new head at the end. So I'll create a new variable. So this will be of type list node, and I'll call this head to represent this is the new head. Now, once we do that, at this point in code, so on line 53, if we ever hit line 53, that means we made it all the way to our base case, which means node.next was null, and it returned node. So remember, that in our example, that would be the last node, which would be 5. So 5 got returned, which means on iteration 4, head is now equal to 5. This has the node 5 in it. Now we can start doing iterations. We can start doing manipulation of the links. So remember, the first manipulation was that weird statement, which was node.next equals node. So that says if we're at 4, go to 5 and then point 5 back to 4, right? This is 4. So my highlighted is 4. Then this is 5. And I'm saying 5's next is 4. That's how it works. And then I need to set 4 to null, so I always make sure the end of this new linked list is null. So I'll say node.next equals null. And then I'm done. All I do is return the head, because remember, the goal is to return the last element, and this last element is going to be 5. And if this is confusing, go back to the demo right before this and watch my little demo again. I did exactly this, but I kept track of the call stack visually so that you can see exactly what happens. But this is exactly what we did in the demo. And now with that done, we can go back and let's just run this program. We should see the reversed list now. There we have it, 5, 4, 3, 2, and 1.